Hello everyone, we start regression analysis, the topic which we explore regression line and regression coefficient. Now what is regression analysis? Regression analysis is a mathematical measure of average relationship between two or more variables in terms of original unit of data. Here we have to note if the variable is in bivariate distribution are related. So we will find that the point in the scatter diagram will be clustered around some curves, that is called curve of regression. And if curve is a straight line, it is called line of regression. Otherwise regression is called curvilinear. So if we have a scatter diagram and if we fit a curve around the cluster of points, so this is a curvilinear or a curve of regression. Now the regression line. Regression line in bivariate study, there are two type of regression lines. The first one, regression line of y on x, that is when y is dependent variable and x is independent variable. And the second one, regression line of x on y. In that case, x is dependent variable and y is independent variable. Now come to the regression equation. An algebraic expression of a regression line is a regression equation. So we have two regression lines. So we defined two regression equations, x on y and y on x. So regression equation is an algebraic expression of a regression line. So the regression equation of x on y is defined by that formula, which is x minus x bar is equal to r sigma x upon sigma y, y minus y bar. Here sigma x and sigma y are the standard deviation and x bar y bar is a mean of x and y. Here the x shows the value of the variable to be predicted and y is a given value of y variable for which the value of x variable to be predicted. Similarly, we define the regression line of y on x, which is defined y minus y bar is equal to r sigma y upon sigma x minus x bar, where y is what is in value of variable to be predicted and x is given value of x for which the value of y to be predicted. Here we have to note x bar y bar are the mean of the x and y series and sigma x sigma y is a standard deviation of x and a standard deviation of y, which we can be evaluated by that formula. And here r is a correlation coefficient of x and y, and which value is always lies between -1 to 1. Now let's take an example. We have to obtain both regression equations from the following informations. Here we have given two series x and y, for which the mean of x series is 18 and the mean of y series is 100 and the standard deviation of x series is 14 and the standard deviation of y series is 20 and the coefficient of correlation between them x and y is 0.8 plus 0.8. So these are given conditions. Summation x bar is 18, y bar is 100, some sigma x, which is a standard deviation of x, is 14, sigma y, which is standard deviation of y, is 20, and the correlation coefficient between x and y is 0.8. So first we find the regression equation of x on y. As we know the formula, x minus x bar is equal to r sigma x upon sigma y, y minus y bar. So substituting the value of x bar, r, sigma x, sigma y and y bar, which is given in the problem. After substituting this value, we get an expression. On simplify, we get an expression x is equal to 0.56 y minus 38. So this is a regression equation of x on y. In the similar manner, we can find the regression equation of y on x. So we know the formula of y on x, y minus y bar, r sigma y upon sigma x, x minus x bar. After substituting the value of these y bar, r, sigma y, sigma x and x bar and solving, we get an expression y is equal to 1.143x minus 79.426. So this is a regression equation of y on x. Now we take another example. From the data given below, obtain the regression equation and estimate the value of x when y is 75 and y is 100. we have given x bar, y bar, sigma x, sigma y, and the coefficient correlation. So we have given the mean of x bar, x series, mean of y series, standard deviation of x and standard deviation of y series, and the correlation between them. So first we find the value of expression of regression equation of x on y. So we know the formula, sigma x minus x bar r is equal to r sigma x sigma y, y minus y bar. So put the value of sigma x sigma y, the coefficient correlation by x bar y bar, and solving that expression we obtain an equation yx is equal to 0.9075y minus 41.14. So this is an equation x on y. In the similar manner, we can find the regression equation of y on x. So we know the formula, y minus y bar r sigma y upon sigma x, x minus x bar. On substitute the value of x bar, y bar, sigma and the coefficient correlation, and simplify, we get an equation which is y is equal to 0.48x plus 67.72. So this is an equation y on x. Now we have to find the value of x when the value of y is given. So we take the expression, the equation, regression equation x on y. Here x is equal to 0.9075y minus 41.14. So because we take the regression equation x on y, here y is independent variable and x is dependent variable. So we put y is equal to 75 in the expression x on y. So we get 26.92, and when we put y is equal to 100, so we get x is 49.61. So we can say when y is 75, so x is 26.92. When y is 100, so x is 49.61. In the similar manner, if we have to find the value of x when the value of y when x is given, so we use the regression equation y on x, because in that case x is independent and y is dependent. Now the regression equation by the least square method. So if we have to find the regression equation by least square method, so regression equation of x on y, so we write x is equal to a plus by. Here the y is independent and x is dependent. So we take an expression x equal to a plus by. So this is the equation of line. So we have to fit that line by the least square method. So we take normal equation by the least square method. We write the normal equation. So take the summation both side. So we write summation x is equal to na plus b summation y, and after multiplying the y both side in that equation and take the summation, we get the equation 2, which is summation xy equal to a summation y b summation y square. On solving that equation simultaneously, we obtain the value of a and b, and after putting that value of a and b in that expression, we obtain the regression equation x on y. In a similar manner, we can find the regression equation y on x. In that case, we take an equation y equal to a plus bx. Here, because x is an independent variable and y is dependent variable. So again, because we are using the least square method, so we take the summation both side. We write the normal equation first, and after multiplying the x both side and take the summation, we get the second normal equation. On solving this equation simultaneously, we obtain the value of a and b and substitute that the value of a and b, we get the equation y, regression equation y on x. Now take an example. From the following data, determine the both regression equation by least square method. So we have given two series x and y, 6, 7, 2, 10, 4, 8. Corresponding value of y is 9, 11, 5, 8, 7. So we are using the least square method. So we know we have to write the regression equation x on y. So we write the normal equation, because we have to fit x is equal to a plus by. This is a regression equation x on y. So we write the normal equations, summation x n a b summation y, sigma x y a sigma y plus b summation y square. So we have to find the summation x and summation xy. So summation x is, we take the summation sum of all data of x, we get summation x is 30, summation y is 40, summation x square. After taking the square of each data and take summation, we get summation x square, which is 220, and in a similar manner summation y square is 340, and I multiply x and y and take the summation, we get summation xy, which is 214. So after put the value of this in the equation 1 and 2 and solve it simultaneously, equation 1 2, we get a is 16.4, b is minus 1.3. so we get an equation x is equal to 16.4 minus 1.3y. so this is an equation x on y. In a similar manner, we can find the equation y on regression equation, y on x. So we take an equation y is equal to a plus b x. Again we write the normal equations of that equation, take the summation both side and multiply x and take the summation both side, and after put the value of summation y, summation xy, summation x square, we obtain these two equations, and solving these two equations simultaneously we obtain the value of a and b, and this value of a and b put in that equation, we get an equation y equal to 11.9 minus 0.65x. so this is an equation y on x by using least square method.